You know, when a death is suspicious, forensic toxicologists are called in to figure out the what, the actual poison. But there's another question that's just as critical, the how. In the world of forensics, the path a poison takes into the body can tell a story of intent, desperation, or just a tragic accident. Let's really dive into why that is.
So, that really gets us to the heart of the mystery, doesn't it? Why is the method of delivery so incredibly important? Well, it's because the choice of route, whether a poison is swallowed, injected, or inhaled, can be the one clue that cracks the whole case open. It's literally the key to unlocking the intent behind the act.
For an investigator, this is the big puzzle. Was this a homicide, where a killer needed something fast and effective? Was it a suicide, where someone was looking for a quick and painless end? Or was it just a horrible accident? The path that poison takes, its route of administration, is a crucial piece of evidence that helps point them in the right direction.
Okay, so let's get a key term straight: the route of administration. It sounds technical, but it's really just the path a substance takes to get inside you. And forensically, we break these down into two major categories. You've got the enteral routes, which take the long way through the digestive system, and then you have the parenteral routes, which are like a direct shortcut, bypassing that system completely.
First up, let's take a look at those enteral routes. I want you to think of this as the poison taking the scenic, local roads to get through the body. It's a journey through the gastrointestinal tract, and believe me, it is full of twists, turns, and a whole lot of obstacles.
Now, this is the most common path you'll see, usually just swallowing something. It's a common method for sure, but it's also a comparatively safe route for the body, and a really slow-acting site for poison absorption. Now, if you're a criminal looking for a quick, certain outcome, that slowness, that's a huge problem.
And this just shows you exactly why it's so slow. I mean, once it's swallowed, the poison has to survive the incredibly harsh acid in the stomach. If it makes it through that, it gets absorbed in the intestines, but then it's sent directly to the liver. And the liver acts like this amazing filter, metabolizing and often neutralizing a big chunk of the poison before it ever gets to the bloodstream. The body is literally fighting back every step of the way.
So from a criminal's point of view, this route is just full of disadvantages. The slow onset means the victim might have time to call for help. The actual dose that gets into the system is totally unpredictable. And all those steps, well, they leave a long trail of evidence for toxicologists to find. So what's the alternative for someone who wants a faster, more direct method?
And that brings us to the parenteral routes. If the gut was the scenic route, this is the body's nonstop express highway. These methods are all about one thing: bypassing the body's defenses to get that poison directly into the system fast.
The goal here is really simple: skip the digestive tract entirely. By doing that, you get a rapid, systemic, and way more predictable effect. This is absolutely the route of choice when speed and certainty are what you're after.
And here they are, the major express lanes into the body. We're talking injection directly into the veins, inhalation straight into the lungs, injection into a muscle, or even just under the skin. Every single one of these is a direct line that bypasses the body's first line of defense, the gut and the liver.
This quote from our source material absolutely nails it. In terms of sheer speed and efficiency, nothing, and I mean nothing, beats inhalation and injection. And that's exactly why these methods are so often the ones we see in homicides and suicides, where a fast, guaranteed result is the goal.
Okay, now what is this number all about? 100%. This represents the bioavailability of a poison that's administered intravenously. 100%. That means every single molecule of that substance enters the bloodstream. There's no filtering, no first-pass effect from the liver, nothing. It's the most direct and potent delivery system you can possibly imagine. So, let's put these two pathways head-to-head. In a criminal investigation, this choice between an enteral and a parenteral route, it's really a choice between two totally different strategies: the slower, stealthier approach versus the fast, brutally effective one.
This investigator's cheat sheet just breaks it down perfectly. I mean, look at the speed. It's slow for oral, but almost instantaneous for intravenous. What about predictability? It's low when swallowed because of digestion, but it's super high when injected. And bioavailability, the amount that actually gets into your system, it's all over the place for oral, but it's up to 100% for IV. This table alone tells an investigator so much about the skill and the intent of whoever administered the poison.
So, after weighing all the evidence, what's the final verdict? Which route is the absolute fastest and which one is the slowest? Let's lay out the toxicologist's definitive list, the final ranking.
And here it is. The fastest route, number 1 on the list, is inhalation. Breathing a poison in sends it from your lungs directly into your bloodstream almost instantly. Right behind that are the direct injection methods, like intravenous. Then we start to slow down a bit with injections into muscle and under the skin. After that comes good old oral ingestion, and finally, the slowest of them all, intradermal, which is absorption through the skin.
So the crucial point, the big takeaway is this. The science of toxicology isn't just about identifying a substance. It's about understanding the pathway it took. A fast, efficient route like inhalation or injection, well, it strongly suggests an intent for a rapid, certain outcome. And that often points to homicide or suicide. A slower, less predictable oral route could suggest an accident or maybe a less sophisticated attempt. The how truly reveals the why.
And that just leaves us with a final thought to chew on. We've gone through the classic pathways, but in a world of advancing science and technology, new, more subtle methods of delivery are always popping up. The big question for the future is, in this constant cat-and-mouse game between poisoners and protectors, how will forensic science evolve to keep uncovering the truth?